For the second subtopic under the applications of spherical trigonometry, we have the nautical mile and parallel sailing. So what is nautical mile? Nautical mile is the linear measure of the angular measure of a distance between 2 points on the Earth's surface in navigation. A nautical mile is the length of 1 minute of arc of a great circle. So it means that 1 nautical mile is equal to 1 minute. Next, since 1 degree is equal to 60 minutes, then the circumference of a great circle contains, so C, that is the symbol for the circumference, equals to 360 degrees because the circle, a full revolution is 360 degrees. And then if we are going to convert it into minutes, so simply you're just going to multiply the 360 degrees by 60. Okay, so we do have 21,600 minutes. Here, so remember, okay, so with the big C, that is the circumference, okay, a full revolution of a circle. Remember, the great circle is still a circle, and a full revolution is 360 degrees. If we are going to convert this into minutes, so it is said that 1 degree is equivalent to 60 minutes. So we can just write it this way. Then multiplying, actually, we can cancel the unit degree. So continuing, we do have C, circumference of the great circle, 360 times 60. So it is 21,600 minutes. Okay, because the remaining unit here is minute. Next. Remember, based on the previous slide, that 1 minute is equal to 1 nautical mile. So it means 1 nautical mile is equal to 1 minute, or 1 minute equals to 1 nautical mile. So since 1 minute is equal to 1 nautical miles, so we can say that what? So the circumference of 21,600 minute. So if we're going to convert it to nautical miles, because our topic is nautical miles. Okay. So converting, it is 1:1. So we do have 1 here. So 1 minute, then 1 nautical mile. Remember, if you are going to cancel the unit, okay, be sure that when you convert, so the unit that will be canceled should be on the denominator. Okay, so let us cancel the unit. So we have minute and minute. It is like this one. So 360 degrees. So in canceling the degree, so the denominator should have the degree. Okay. So the circumference is 21,600. Then copy the unit here, the NM. So we have nautical miles. You can also write it this way, N then miles. Okay. Next. So continuing, so I will remove the writings. Since the circumference of any circle is c equals to 2 pi r, and r is equal to 3,959 statute miles for the terrestrial sphere, the Earth, then we can see that the circumference is equal to 2 pi times the r, which is 3,959. It is equal to 7,918 pi statute miles. So 1 nautical mile is also equivalent 1.15078 statute miles. And then it is also equivalent to 6,076.115 feet, and also equivalent to 1.852 kilometers. Okay, so these are the equivalents of 1 nautical mile. Next. So we do have here a problem. So find the distance in nautical miles between 2 points. So we do have a point A, so that has the coordinates 42 degrees, 20 minutes north, 35 degrees west, and point B coordinates are 71 degrees, 40 minutes north, and 35 degrees west on the Earth's surface. So how are we going to solve for it? What we can solve from this, so considering the distance, is the difference in latitude. So if you remember the discussion in the topic terrestrial sphere, so we have there the concepts about difference in latitude and difference in longitude. So why is it that the difference in latitude is the one that we are going to consider here? Okay, so if you try to draw, point A is 42 degrees 20 minutes north. So this is actually the what? The latitude. So it is the latitude. Okay. So for the latitude, remember the measurement is actually from the equator. So let us have the equator here. So this is the equator. Next, we're gonna measure 42 degrees 20 minutes north. So the north is here, right? So this is the 42 degrees 20 minutes north. Okay. And then the longitude. So this one is the latitude, the other one is the longitude. The longitude is 35 degrees west. So remember, the longitude, it is measured from the, so longitude, it is measured from the prime meridian. So the prime meridian is a meridian from the north going to the south. So if we do have the prime meridian here, so from the north going to the south, so we have here the south. Okay. So you're going to measure, okay, you're gonna measure 35 degrees. Example, the 35 degrees is here, okay? So this is the 35 degrees. And then it means that the point of intersection of the 42 degrees, 20 minutes, and the longitude 35 degrees, it is actually the point A. So this is point A. Okay, next. Another point, which is B. So B is 71 degrees and 40 minutes. So this is again latitude. So the measurement is from the equator towards the north. So from the equator towards the north, you're gonna measure 71 degrees and 40 minutes. Okay. Then you just draw a small circle here around. And then the longitude. So the longitude, if you try to locate it, so the longitude is 35 degrees from the primary region towards the west. So again, if our primary region is this purple, okay, so we have here the primary region. So towards the west, so measuring at 35 degrees. So we have these 2 points, okay? This is the point of intersection of the latitude and longitude, and this is point B. So if you try to notice, the 2 points do have the same longitude. So let us consider the latitude because the latitude are what? Different. So what we are going to consider here is what? So from point A, okay, so we have the point A and also the point B. So what is being asked is the distance. So this one. So if you try to notice, the distance here is actually what? The 71 degrees 40 minutes minus 42 degrees 20 minutes. And then by getting the difference, so you can just use your calculator. So the answer is 29 degrees and 20 minutes. Okay, that is for the difference in latitude. By the way, by the way, what is being asked here is the nautical miles, distance in nautical miles. So it means that this answer in the difference in latitude, we need to convert this to nautical miles. So what are you going to do with this? So first, you can convert it to degree first, okay? Because this is in DMS. So have it in degree first. So with the decimal, okay? With the decimal. So that is 29.33 degrees. So we have the answer here. So let us just write the solution. So since the difference in latitude is 29 degrees and 20 minutes, so this one, it doesn't have the direction whether the difference in latitude is north or south, because what is being asked here is difference. So what is the difference in latitude between? Okay, between. So there's no sailing or traveling yet from one point to another, no. What is asked is distance between. Okay, it is very clear. It is between. So the first thing that you need to do with the 29 degrees and 20 minutes, so convert it into decimal. So that is 29.333. So just use a 425 decimal. We have here degree, and then next you're gonna convert it. So 29.3333 degree, you have to convert it to minute. So in converting it to minute, again, if we need to cancel the degree, so in the denominator we should have the degree unit also. Okay, and we know that 1 degree is equal to 60 minutes. Okay, so with this, we can already cancel the unit degree. And then, So I'll just make it clear. So 29.333. I'll just rewrite this so that you can see. Okay. So you can use your calculator. Then so 29.3333 times 60. So we have 1759.998. But then remember, the 29 degrees and 20 minutes is actually 29.33333. So we do have the repeated 3. This is equal to 1760 minutes. Okay, this is in minutes. So again, we need the nautical miles. So we need to convert this to nautical miles. So we have what? So we have 1760 minutes times. Okay, we need to cancel the minute here. So we're going to have the minute in the denominator. So remember that conversion is 1 is to 1. So we have 1 minute is equal to 1 nautical mile. Then we can already cancel the unit, minute. Okay. Then the answer here is what? 1,760. Copy the unit, nautical miles. So this is the distance from distance between A and B. So that is the reason why we do have this answer. Okay. Actually, the final answer here is the one with the nautical miles because it is what being asked in the problem. So this one is the answer because of nautical mile. Okay. Next. In parallel sailing is sailing due east or due west along the same parallel of latitude. The parallel of latitude was discussed already. When we say parallel of latitude, if we do have points, the said points, so whether we do have 2 points, 3 points, um, they do have the same latitude. So like this. So we can say that here, so point A and point B are what? They do have the same latitude. So from the equator, okay, so from the equator, they do have the same latitude. And therefore, we do have the parallel of latitude. In parallel sailing, so consider now the arc AB in the figure. So it is what I was saying that A and B are points with the same parallel of latitude. And then it is said that the length of arc AB in nautical miles is called the departure between the meridian of A and that of B. So if we have here point A and then point B, since these two, okay, since these two have the same latitudes, so we can get actually the departure that is denoted by D. Departure is the length, okay, the length of the arc AB. In navigation, arc AB may represent the path traced by a ship which sails from A to B. Okay, so if we have the points A and B here, so we do have the departure. The said departure can be from A to B. And we can say that it is due east. Okay, from A to B, it is due east. If we have from B, from B to A, it is due west. Next. Since the departure is the length of a small circle, okay? So as what you can see, if we have A and B here, so this circle is a small circle because the center of this circle is not the center of the sphere. The relation 1 nautical mile equals to 1 minute does not hold. Okay? This is actually 1 minute of arc. So let us just correct it. Next, departure. So what are we going to use if we are going to solve for the departure? So the formula for the departure is d equals difference in longitude times cosine of the latitude. By the way, class, possible that you can see the difference in longitude. It can be well written as the long. Okay, then the latitude. So we have here the lat. If difference in latitude, so that is the lat. Okay, possible you may see terms, symbols, or short term for this difference in longitude, difference in latitude, longitude, and latitude also. So let us have an example. Leaving latitude. So for example, there is a ship, and it's well, the current coordinates are 50 degrees 25 minutes north and 82 degrees 36 minutes west. And then the said ship sails due east and then reaches with a longitude of 78 degrees 24 minutes west. So the question here is find the departure. Okay. So if you try to imagine, so let us have a circle. So ship leaving latitude. So let us have here the equator. Okay, so this is the equator. And then we do have here the prime meridian. So why is it that the prime meridian is, well, somewhere on this portion, okay, on the right side? We're gonna put the longitudes here on the west. So that is the reason why the prime meridian, we put it on the right. Okay, so we have the prime meridian here. So this is the prime meridian. Then latitude of 50 degrees, 25 minutes north. So from the equator, we're gonna measure 50 degrees. So for example, the 50 degrees is here. So this is 50 degrees, 25 minutes north. So we're gonna have a small circle here, okay, on the said 50 degree and 25 minutes. Then next, so longitude, we're gonna measure 82 degrees and 36 minutes west. So from the primary region, so say that this is, for example, 90. So the 82 is somewhere here. Remember, class, the latitude is 0 degree to 90 degrees. Okay, because it is from the equator then to any pole. So North Pole or South Pole. For longitude, if you can remember in the discussion, okay, in the previous topic, the longitude is 0 degree to 180 degrees. Okay, so 82, so say that this is the 82. The point of intersection is what? This one. So this is the where the ship is before leaving. Okay, so this is the point A. Next, sails due east until it reaches longitude of 78 degrees. So its direction is to the east. So going to the east, and it is said that it reaches, okay, it reaches this point in which the longitude is 78 degrees. So let us just put here the 78 degrees. 24 minutes. The other one, it is 82 degrees and 36 minutes. Okay, so it is the point B here. Now, so if you try to notice, this is actually parallel sailing. So why is it parallel sailing? Because in our drawing, you can see that both do have the same latitudes. They only differ in the longitude. So that is the reason why we can use the formula for the departure. So D equals to the difference in longitude times cosine of the latitude. So in the difference in longitude, so remember if the two longitudes, okay, the two longitudes here do have the same well, so can be both in both west or both east. So what we do in the difference in longitude, we do subtract. Okay, we do subtract. So you're gonna subtract the smaller one from the bigger one. 82 degrees, 36 minutes minus 70 degrees, 24 minutes. So that is the difference in longitude. Times cosine of the latitude, 50 degrees, 25 minutes. Next. Um, the difference in longitude is 4 degrees, 12 minutes. And then the next thing that you need to do, you need to convert this to minute, then to nautical miles. Okay? If you want, if you do have the DMS, so the easier way is to multiply it by 60 right away, and then consider the decimal. That's what you can do. Then multiply cosine 50 degrees and 25 minutes. So the answer is 160.57 nautical miles east. So why is it east? Because remember in our drawing a while ago, so we do have point A. Okay, point A with a longitude of 82 degrees and 36 minutes west. And then it is said that the ship is due east. So going to point B with a longitude of 78 degrees and 24 minutes. So the ship is actually what? Heading east. So the departure is this. So another problem, a ship has an initial position of 60 degrees, 7 minutes south. Then 22 degrees, 35 minutes west. And then it sails due west for 1,571.93 nautical miles. So what is the longitude at its point of arrival? So remember the formula for the departure. So it is D equals, so difference in longitude times cosine of the latitude. So in our problem, we do have the 60 degrees and 7 minutes south. So this is latitude because it is south. And then 22 degrees, 35 minutes west. So this is longitude. And then what else? So we have the given here 1571.93 nautical miles. This refers to the distance traveled. Okay? So this is the distance traveled. So therefore this is the departure. What is the longitude at its point of arrival? So we need the second longitude, or the longitude at the second point. Considering that this is parallel sailing, so the latitude will be the same. Okay? So in this formula that we have here, so we can try to analyze it. So we do have the departure. For the difference in longitude, we don't have. Cosine of the latitude, we have the latitude. So it means we need to determine first the difference in longitude. So we're gonna derive. So derive. So in deriving, so since we have d equals to difference in longitude, cosine of the latitude, so we need to remove the cosine of L on the right side. So we need to divide both sides by cosine of L and then cancel this. So we have the departure over cosine of latitude equals to difference in longitude. Next, this difference in longitude can also be well written this way. So difference in longitude equals to d over cosine of L. Now let us substitute first. So the departure is 1571.93 nautical miles. And then we do have the cosine of the latitude, 60 degrees 7 minutes. So since the departure is in nautical miles, so you need to convert this first. Okay, try to convert this. So we have 1571.93 nautical miles. So we have times 1 nautical mile is 1 minute. Okay, then we can try to cancel the um, units here. So what will be left is degree. Then you can just input it directly in your calcu. Then divide by cosine of 60 degrees and 7 minutes. Or if you want another way, you divide first the 1571.93 by cosine of 60 degrees and 7 minutes. Then after that, you convert to degree the answer. So we have the difference in longitude, which is 52.58 degrees. So we have the second longitude. So it is the first longitude plus the difference in longitude. Okay? Then, so if in the first longitude, or the first longitude is 22 degrees and 35 minutes, so we're gonna add the 52.58 degrees. So the second longitude would be, so you just use your calculator, 75.1665. So use the degree, minute, and second. So it is 75 degrees, 9 minutes, 59. So 9 minutes, 59, that is 59.62. So it is 60. So we can write it as 10 minutes already. So we have here 10 minutes. And then is it west or east? So of course, it is what? It is on the west. So this is the longitude at the point of arrival. Try to think of it. Why is it west? So remember the first longitude is on the west. Okay, it is on the west. And then the ship sails due west. So of course, the second point has a longitude of, well, it is also on the west. So that's it for the parallel sailing.